In this video, we're going to be talking about the color wheel project, specifically how to draw the schematic for the project in the electrical engineering unit. First, let's talk about what a schematic is. Basically, a schematic is just a drawing or a graphical representation of a physical system. And instead of using detailed drawings, we're going to use simplified or very simple symbols to represent the components that we'll have in our system. So let's take a look at a really simple example. Over here we have a picture of just an LED circuit. You can see the battery, that's our power source, and the current flows from the battery through a resistor, then through the LED, and then back to the negative terminal on the battery. So a schematic of this system is shown here on the right. Representing the battery, we have this little symbol right here. That's a typical symbol for a power source or a battery. I've labeled it 9-volt battery so that we know what it is. And this little zigzag line is the symbol for a resistor. And a triangle with an arrow pointing in the direction of the current, and then a little line there is an LED. We have a little arrow here to show that light is coming off, so it's not just a diode, but it's a light emitting diode. And we have the arrow specifically in the direction of the current because LEDs don't like to have current go backwards the other way. So this is just the schematic, and then the connectors in between are just the wires that show that we are connecting battery to resistor, resistor to LED, and LED back to the negative terminal on the battery. So what would an Arduino schematic look like? Here on the left we have a picture of what the Arduino board actually looks like, and connected here is just another little LED circuit. We connect one of the digital I/O ports through a resistor to the LED and then back to ground. The schematic of what this circuit is over here on the right. We have a very simplified representation of the Arduino. This is showing me all of the ports. So on the right side are the digital I/O ports. On the left side I have my analog input ports, and then I have pins that look like ground. So G and D represents any ground pin on the Arduino, and then 5-volt would represent any 5-volt pin on the Arduino. So if you look over on the picture on the left, you can see there's a ground pin over here, and there's a ground pin over there. Either one of those are connected to ground, and we just represent that as one single pin. So you can see here the schematic shows that there's a connection to the digital 13 pin through the resistor, through the LED, and then back to ground. So that's a very simple schematic of how we would use the Arduino inside a schematic. The LED schematic, let's take a look how we represent LEDs in a simple schematic. So picture of the RGB, red, green, blue LED is shown here. We can see that the different leads have different lengths, the longest one being the common cathode. The one that's short and just next to it all by itself is the red, and then green and blue. If we look at the technical or data sheet, the technical diagram on the data sheet, it shows measurements of that LED, a little more specifics for the size and the representation of the pins. And here we can also see that this is the common cathode, and the one all by itself here is red. Next to the common cathode on the other side is green, and then finally blue all the way on the other side. Over here we can see a schematic of what that LED looks like on the inside, where this is red, green, blue, and then the common cathode is shown on the other side. Something to note that's a good thing when we're building our circuit is that once the pins are in the breadboard or connected, sometimes it's really difficult to tell what is the cathode and what's red, green, and blue. If you take a look at this drawing, um, they've got this little lip around the dome over the LED, and on one side, on the red side, that lip is flush with the rest of the dome. So it's easy to see once we have it plugged in which one the lead is. It's the red lead. The red lead's just next to this side where the lip is just flush with the rest of the bulb. So this is a schematic of an RGB, or red, green, blue LED. Over here on the bottom right, this is how we're going to represent a RGB LED. We're going to show it as just 3 LEDs, which is basically all it is, inside the dome. There's a red LED, a green one, and a blue one, and they all 3 share a common cathode. So that's how we can represent as a schematic an RGB LED. The Hall effect sensor is what we're going to use in our project in order to tell the lights to start drawing, or tell the Arduino when to start flashing the lights. So a Hall effect sensor just looks like this little 3-pronged sensor component. Let's take a look at the technical diagram from the data sheet to see what each of those leads means and represents. This is showing basically the internal electronics in the sensor. We don't have to worry too much about that, but what we need to know is how to use these leads. And these are the leads shown from the imprinted or beveled side. So there'll be a stamped number and series of numbers and letters on the front side. And when you're looking at it from that stamped side, usually with the bevel up, from left to right, the leads represent the supply. So this is where we're going to supply the sensor with a voltage. The ground, this is where we will connect it to complete the circuit. And then an output. So the sensor output, the signal that the sensor is going to send to the Arduino, needs to be connected to this lead, or will be coming from this lead. So just a simple schematic of a Hall effect sensor will look like this, with 3 leads represented in this way. We'll have a 5-volt supply coming to the supply lead. The ground lead is showing going to ground, and then the output will have, typically on our Arduino, we'll send it to the analog 0 input. But it doesn't have to be analog 0 as long as you just make sure you're specific, so your software person knows how to program where the input from the Hall effect sensor will be coming from. The last thing that we kind of need to understand when we're drawing a schematic is what connections look like in a schematic. First, over here we can see that we represent connected wires with a little dot. So that means that we have a connection here between this, maybe an incoming wire and an outgoing wire, so that we can have current flowing to both of these places, and also the same voltage potential on all of these wires. Next, we can show wires that are crossing but not connected. Oftentimes that will be shown with a little bump over a wire coming down. It also can be shown with just crossing wires. These just wires are crossing in the schematic, but they are not connected. And lastly, if we have a really complex schematic with wires going all over the place, sometimes we represent a connection by a label. So if we have a wire coming from one place and we don't want to connect it all the way through our schematic, we can label it over here, red 1, and we can look over on the schematic in another place and see a label red 1, and then we know that this wire is connected to this wire over here. So red 1 is connected to red 1. So let's put it all together and take a look at what the overall schematic should look like for this color wheel project, or persistence of vision POV project. Here I have drawn my simplified Arduino and showing all of my digital input-output pins and my analog input pins, ground and 5-volt supply pins. And so we're going to show how all of that needs to be connected together to do this project. First, I'm going to start with showing my LEDs. For the project, we have 8 LEDs, so I'm going to draw all 8 of them. Again, these are red, green, blue leads, and this is all connected through each LED to the common pin. Next, I want to show that I'm connecting a resistor to each of the common pins on all 8 of the LEDs. And then I'm going to show a little label here. This will become obvious what this label is for in a minute, but this will show me where I'm going to connect this common pin from my LED, from my resistor, into the Arduino. And as we've talked about in other videos, we have to share leads for the color supply, or for the voltage supply for the color leads for each of the LEDs. And we do this so that we can deal with the limitation in pins from our LED. So for the red lead, we're going to connect 4 LEDs together on their red lead, and you can see I have a little connection point here. So all 4 of these LEDs, their red leads are connected together, and I'm going to label that red one. Same thing for green and blue. You can see all the greens are connected together and all the blue leads are connected together for these 4 LEDs. We can only do 4 of them at a time because each pin on our Arduino can only supply 40 milliamps. Divided that by 4, we get 10 milliamps per LED if all of them were on, and that's a reasonable current for the LEDs to operate on. Same with the other group of 4 LEDs. I've now labeled this red 2, and all those red leads are connected together, green leads and blue leads. Let's take a look and see how I connect this to the Arduino. So here you can see now I've labeled this red one is going to be connected to the digital 13 pin, red 2 to digital 12, and similarly on down through the colors. And then here you can see where I have my rows connected. Row 7, 6, 5, etc., all the way to row 0. Counting from 0, which electrical engineers and computer scientists like to do, count 0 to 7, that means there are 8 LEDs. So you can see by following these little flags what is connected from the Arduino to the LEDs over here. Lastly, we need to show how our Hall effect sensor will be connected. We have my little sensor over here, and I can show that the supply is connected to the 5-volt pin on the Arduino, that the ground is connected to the ground pin on the Arduino, and that my output for my sensor will be connected to A0. Now you don't have to connect these wires to these numbers. I could connect the Hall effect sensor to A3 or whatever analog input I want to, as long as the schematic shows it and has it labeled so that the software person in your group can program properly. Same thing with the color pins and the row pins. Doesn't matter what they're hooked up to. I could have hooked them up completely differently as long as my schematic reflects how the hardware is hooked up, and so that the software programmer can program it properly. Hope this helps you set up your schematic. You should be able to now draw your own schematic for this project.